Hello, I am Mendy Mombeshora, and today I'm going to be presenting to you the case of Photogen's NetCam. This is a case that I designed to introduce the concept of three-dimensional concurrent engineering and to highlight its potential benefits in an industry-based setting. So, introducing Photogen. So, Photogen is a company that specializes in the design and development of cameras. The camera product development has three distinct but equal drivers. One is core capability. This means that when they design their products, they aim to utilize their core capability, which is how good they are at designing cameras. And in turn, the more products they design and develop, the stronger the core capability becomes. The second is corporate value proposition. This means that through the product development, they want to make money, and the more money they make, the more that they can develop. And the last one is customer value proposition. This means that they aim to design and develop products that customers value, and then in turn, they can sort of take the values of the customers and incorporate them into their product's development process. So, one of the sub-industries that Photogen competes in is the travel camera industry. This is an industry that can be seen as having a fast product clock speed. This means that the life cycle of the products within the industry is pretty fast. This relates to how often a company has to release new products in order to stay competitive. So let's take a closer look at Photogen's product releases. So Photogen was actually the company that first started this sub-industry. They were the first company to design a camera that was specifically targeted at travelers. So the first product release, the development of it took over 2 years. They took their time to design the ultimate camera for the travel industry. And then after that, using a vertically integrated model where they were in charge of everything from manufacturing to R&D, they sort of had steady releases of new generations of the product once every 2 years. However, they found that the industry was evolving. The industry started having shorter product life cycles. There were higher market dynamics, and the technology that was involved was rapidly evolving. And really, Photogen found that they were not able to compete. Their product development was just taking too long compared to some of the competitors. So taking a closer look at the industry clock speed versus their product releases, you can see that the first release, that was early. The second release, which took 2 years, was just on time. However, the third release, which for them came after 2 years, it was too late to come into the market. And so they realized that in order for the fourth release to be almost on time, they had to do something different. It was at this point that they switched from having a vertically integrated model to incorporating more of the supply chain by having more of an open innovation-based model. So within that model, they found that for the fourth generation product, that was going to be almost on time, cutting the product development time to about 1.5 years. But that was not enough. They knew that for the fifth generation, they would need to cut down the product development time even more if they wanted to release the product on time. So, looking at the fifth generation camera, they decided that they were going to design the NetCam. This is a camera that would pose certain challenges to Photogen and what they are good at, which is essentially the design of a camera. In this camera, they had to make sure the camera incorporated videoing capabilities, that it could compete with things like laptops and mobile phones, since people start using that as they travel to take pictures. It also had to be environmentally competitive. This was the driver coming from their customers. That's what their customers wanted. And also, it had to have a function that incorporated social media. So there were a lot of different things within this new product development that Photogen did not really have the expertise in. However, with the open innovation model, they knew that they could go to the supply chain and they could find people with the right expertise and they could collaborate just like they had done for the development of the fourth generation model. Under the open innovation model that they had, supplier collaboration had given them a lot of benefits. However, they were looking to take that further. They were looking for the next step when they were designing the fifth generation model. And that's why they looked at three-dimensional concurrent engineering. So in its simplest form, three-dimensional concurrent engineering is the simultaneous design and development of the product, the process, and the supply chain. It can be seen as sort of the evolution of the traditional concurrent engineering process, which matches the product and the process. So, this is a brief look at the past, the present, and the future of Fortigen's product development process and how it was structured. So back when they had 2 years to develop their products, basically they practiced concurrent engineering. So they would design simultaneously the product and the process, and then later on they would start designing the supply chain. However, all that was done internally and without any collaboration with any external partners. When they moved to an open innovation model, they started incorporating the supply chain into various different activities. So they were outsourcing some of the manufacturing and design, they were collaborating with the suppliers in the actual design of the products that they had, and even in building a more dynamic supply chain, they were actively involving the supply chain. So with the fifth generation, as they looked towards three-dimensional concurrent engineering, Fortigen are looking to simultaneously design the product, the process, and the supply chain, all with the help and collaboration of the supply chain. So this is sort of taking step 2 and then putting everything else in parallel. When they started involving the supply chain, it meant that they could have a collaborative advantage within the design process. So there were design chain supplier relationships where the design teams would work with other design teams. They would have more knowledge and know-how in developing new products. And then within the supply chain, they would capitalize on the resource-based view that says that a company can be competitive based on the relations that they have with other companies within the supply chain. And within that, they had supply chain relationships within the supply department. So the idea behind three-dimensional concurrent engineering is that you can combine these two different forms of advantage. You can combine them and use the various supply chain relationships that you have within your company to support your product development process. So even your supply chain relationships within the supply department can be utilized within the product development process, and those relationships in the product development process can also be utilized in the supply department. So in a way, breaking down some of the internal walls that you have when it comes to collaborating with your supply chain. So this would be of particular importance in the development of the NetCam, because as you can see, they needed capability that was outside of the firm's boundaries. They needed a way of connecting it to social media, and by having more interaction with the supply chain, they would have more complete information and support from the supply chain itself, and environmental performance of the product was directly dependent on the various members of the supply chain, because the environmental performance is an amalgamation of all the different parts that are in there. You need to consider everything holistically. So to do that, they needed to have the support of the supply chain. So really, this is in a way where the G.EN.ESI project comes in. Some of the tools that the G.EN.ESI project is developing are tools that will support a company like Fortigen who wants to conduct environmental product development. This is done by sort of having a focus on the supply chain, trying to strengthen the collaboration with the supply chain and their input, and help promote having information and support from the supply chain during the product development process. So one of the tools that will be of benefit is the supply chain mapping tool. This is for supply chain awareness. So before you can design a supply chain, before you can outline who does what, it's important to actually understand how much you know and where you stand. So a baseline that you can measure. And through this, you can understand the architecture of your supply chain. You can aim to build a certain supply chain, and you can understand how value moves and migrates within your own supply chain. Another tool that would be useful is the web-based supply chain information sharing portal. This really is a key in integrating environmental considerations into the product development process. This is because when you do environmental assessments, it's important to have as much information as possible. So when you're designing your product, if you assign various bits and pieces of information, accurate information, to your design, then you can do a more complete environmental performance. So in this case, it's a case of getting information from your supply chain and then adding it directly to your design, and then performing environmental analysis of your design. This is something that can be done using the G.EN.ESI platform. And then, basically this shows how important it is to have a basic understanding of your supply chain, because there's so many various actors in here, and each one of them has an impact on the environmental performance of a product. So for Fortigen to create the NetCam and to know how environmentally competitive it is, it has to have information from all these different actors. So that was just a quick presentation to introduce the concept of three-dimensional concurrent engineering in an industrial setting, so you could see where a company might choose to use 3D CE and how that can aid in the integration of environmental considerations into the new product development process, and also cut down product development time. This presentation has been brought to you by the G.EN.ESI project, and if you have any questions, please feel free to ask. Thank you.